Hello and welcome to SudoKanard. Let's have a look at this inclusion Sudoku puzzle that was created by myself and featured on the latest round of the WPF Sudoku Grand Prix. Well, actually, when I submitted my booklet with puzzles, I named it Quadruple Sudoku as it's the trend in the community to denote quadruple any variant when you have a circle with digits at the intersection of 4 cells, and that means that each of the digits has to appear somewhere in those cells. So the organizer of the WPF Sudoku Grand Prix thought it would be better called inclusion than quadruples, because quadruples would mean 4 values for the 4 cells. But the ironic part of it is that the main logic is actually exclusion, not inclusion. So how do you start? Oh, before starting, I must say what was my intent was to have here three sets of 3 digits that span digits from 1 to 9. Here you have a whole set of digits 1 to 9. That's the same here, the same here, the same here. And I was wondering, how can I do a puzzle that works with basically almost only that as clues? And I put just clues with 2 values here, 1, 2, 3, 4, 7. So, and there was a lot of logic to explore. I come to the real solve in a moment, and I hope I will remember all the stuff that was intended, but it's not certain. So some of the logic that is really common is to search for commonalities. That is, there's a 2 here, there's a 2 there. So on this row, 2 has to appear somewhere here. The same happens here with 6s. You know that there has to be a 6 here. The same happens here with 3s. So there has to be a 3 here, and using this one there's a 3 there. So there's a 3 somewhere here. And at last here, with this and that, you know that there has to be a 2 here. But apart from this 3, that's not so useful actually. But this 3 and this 3 are more useful because there has to be a 3 somewhere here, and it can only be in this cell. Now you see there's a 2, 4, 6 triple in here, and 1, 5, and 7 must be here. So that's a kind of exclusion. So because 1 digit is here, you see that the 3 digits that I mentioned have to be elsewhere. The remaining 2 digits are 8 and 9. And then there's something quite hidden. You know, there must be an 8 somewhere here, but because of this, 8 won't be in this cell, so 8 will be either here or there. And why is it useful? It's useful because this 8 interacts with the 8 that is in the 8-9 pair. Namely, if 8 is here, then you have an 8 there. If 8 is not here, then you have an 8 there, which makes this 9 and this 8. So you know that that 8 in this column is either here or there. And therefore you don't have an 8 here, and you don't have an 8 here. So there must be an 8 in one of those 2 cells, and there's no 8 here. And that is very useful if you consider that none of those digits 1, 2, 7, 3, 6, 9 are in this cell. But 4 is not in this cell, and we now know that 8 is not in this cell. So 5 is the only remaining candidate for this cell. So that's what you would call a hidden symbol. And you see that now 5 can't be in either of those cells. So this is a 5-8 pair inside this quad. But there's a 5 somewhere here, which means that this can only be 8 and this is 5. This 5 and this 4 make now this a 4-9 pair. sorry, the wrong notation. So that's a 4-5 pair. And 1 can't be here because of the given 1, so that's a 1. Now 2, 3, and 6 and 8, sorry, must be in those cells. And the remaining 3 cells must be 6, 7, and 9. And there, 6, 7, and 9 are not in this cell, so they must be here. But you see that this will never be a 7, and it will never be a 6. So that's a 9. And we have a 6, 7 pair here. And the interesting part of this, no, that doesn't work, sorry. I'm mistaking this for some palindrome logic. Now, what do we see? Well, something interesting there is this cell. This cell can't be 9, obviously. It can't be 1 or 2. It can't be 7 or 8. It can't be 5 or 6. So it has to be 3 or 4. But it's not 4 because of the given 4. So this is a 3. And we know we have a 3 somewhere here. And that doesn't seem to be important. There will be a 4 somewhere there. 1 and 2 here, 7 there, 5 and 6. 5 is here actually, so that's a 4-5 pair. 6 must be here. And we get a 1-2 pair here. And 7 can only be here, and that's a 6. 8 here removes 8 from this cell, so it has to be a 9. That's an 8. And it resolves the 8-byte pair here. We can also note that there's a 4 somewhere here, so that 4 is not here. What next? Next, this 3 tells us that the 2, 5, 7 triple is here. And this 2, 5, or 7 says that this is now a 1, 3, 6 triple, but there's already a 1 in this column. There's already a 3 on this row, and that's a 6. This is not 6. This 3 is now removed from this cell. So there's a 3 here, but I don't think it's useful to pencil anything about this. There's a 4, 8, 9 triple here, but actually there's already a 9 here. So that's a 9. And that's a 4, 8 pair. So we have a 4 here, we have a 4 there, and on this column, 4 can only be here, which resolves the 4, 5 pair. So now, because of those 4s, there must be a 4 here, but we know that there's a 4 somewhere here, so 4 is there. And this quad Q is now fulfilled. The remaining digits here are 2, 5, and 7, so we have lots of 2, 5, 7 triples, and this one is the most interesting, I think, because it says that this has to be a 6. So 7 is pushed here in this quad, and this must be 9, and there can't be a 2 here because there's a 2 in one of those cells, so that's a 2. There's no 9 here, so this is a 6, 7 pair, that's not 7. And we know that this can't be 8, so 8 in this column must be here. With this 4, that's a 5, that's a 4. This can only be 2 or 5. That's a 7, 8, 9 triple. So this can only be 7, this can only be 9, that's 8, that's not 7. The 2, 5, 7 triple here puts a 4 there, and a 1 there, which resolves the 1, 2 pair. This 2 puts a 5 here, that's a 2, that's a 2. Oh, and this can't be a 7, so that's a 5. We can remove 5 down there, so that's a 5. And this is a 2, 6 pair, so 2 is here, 6 is there. This 2 also puts a 2 here. So we're slowly getting there. This can't be a 4, so 4 in this column is here, and the remaining digit is a 1. This column needs a 6 and an 8. This can't be a 6, so that's an 8, and that's 7. That's a 6. Here we need 3, 8, and 9. So that's your 8. 3, 8, and 9. 2 and 7 here, they must be here in the quad. And there's a 1 here. 3, 8, and 9. This can't be 3 or 8, so this is 9. And this is a 3, 6 pair, so that's 6 here, 3 there. This is 8. That's 3, that's 9. That's 8, that's 3. That's 7, that's 6. 1 here. Don't have this. Oh, this 2 here puts a 2 there. Here we need a 5 and a 7, so that's 7, that's 5. That's 1, that's 7. 2 and 7 here. 6 and 2. 1 is not here, so it's there. That's a 4. That's 8. That's 1. That's 9. And that's 6. And this finishes the solve of this puzzle, called quadruple Sudoku or inclusion Sudoku, as you like it. And it was one of the latest puzzles that I submitted. Or well, I submitted the whole booklet in one file, but it was one of the last puzzles that I created, and I must say I was very pleased with it. So, and I'm very glad that it made the cut, that it was featured in the actual round. So thanks for watching this video, and see you soon on SudoKanard.